You all are doing okay. It's not like a mixed bag based on those responses. I got in on flight at right at like 10:30 and then I had to make it back to my house and wake up, but it was a nice trip. But excited to be back with you all. Today we're going to talk about recursion. Before we get into that, I'm just wondering how you all are feeling about this data structures and algorithms, sorting and searching content. We've had a little bit of time to not have to look directly into our algorithms, a little bit of a break. How are folks feeling about things? Folks feeling excited today? Are folks feeling nervous? What's the feeling? Has this all been so easy? So you're just like, where's the difficulty? Let's ramp it up. Maybe that's the feeling. All right, Tatiana's saying it's cold and cool, so hopefully that's I don't know, we can warm up with some recursion, perhaps. Perhaps that'll help. Any other thoughts on the content from past few days? If you all have been thinking about it. Yeah, Amr says, wouldn't say nervous, but I don't really know what to expect from recursion. Definitely has not been easy though. Tatiana agrees, content is challenging. Yeah, this is definitely tough stuff. I hope having a little bit of time away from it can perhaps alleviate some of the immediate stress, right? When we're learning something new and big, it can definitely feel really overwhelming. Uh, but I think at this point, we're going to take a little tiny bit of a detour into a new programming concept to give you a little bit of a break from sorting stuff. And just as a reminder for this entire module, our goal really is to just improve our critical thinking skills, to look at some interesting and often used algorithms. So again, I hope the stress isn't coming from feeling like, okay, I need to memorize all this and make sure it's 100% in my head, as much as it's important to make sure you can think through these problems, read through algorithms, pseudocode out uh, ideas that you have, just to make sure that, yeah, you're developing those skills. It's really one of the most important parts of programming. All right. Omar's already switched back to I'm fine background, so I think we're starting good, starting with some good vibes. All right, well, let's go to recursion. Let me go ahead and share my screen here. I think this is really cool. I think this is like a really fun lesson. It's really a neat thing. It's also something that like is not in terms of a daily programming job, like not the most necessary. So it's something you can like be interested in and also feel like I have time to understand this. I think that's maybe a good way to think about it. But it's really, I think, going to be interesting and fun and weird to kind of look through how this works. All right. Oh, thank you, Tatiana. The cat background is really balancing out the this is fine dog background. So we got some multiple vibes going on. I appreciate that. All right, excellent. For today's lesson, we're talking about recursion. We're going to learn about recursion, a programming technique where a function calls itself, and you'll understand its use cases and how to implement recursive solutions in JavaScript. By the end of this lesson, you will be able to understand the concept of recursion in programming, write recursive functions in JavaScript, and identify scenarios where recursion is beneficial. I really do think we're going to be able to get through all of those today. I know some of the previous sorting algorithms, I think the objectives or the goals or something like, we're going to learn this sorting algorithm, and maybe that makes it feel like we have to have it 100%. I think these ones are very doable. We can write recursive functions. We're going to write at least two of them today, three of them today. We'll understand the concept and we can identify some scenarios where that's useful. And we'll end up using it tomorrow with our next sorting algorithm. All right, first of all, quick warm up. Let's put some code back into our brain. What do y'all think will be the result of the following code? What do y'all think would be the result of the following code? All right, excellent. Thanks so much, Omar. Yeah, so in this case, we take a look at this code. We've defined a names variable that is an array of names. We've set our index to 1, or sorry, our index is 0. Hello. And then we are saying while the index is less than the names.length, we're going to run this code inside of this code block. Inside that code block, we grab the name at that specific index, and then we say welcome that name, and then continue to do that until index is no longer less than names.length. But there's no line of code in here that adjusts index in any way that would move us to actually ending this loop. So in this case, we'll end up with an infinite loop. I'll just constantly say, welcome, Dylan, welcome, Dylan, welcome, Dylan. We're really excited Dylan has joined us today, I have a feeling, because of this code. So it's important to remember we'll need to be thinking about how to stop any kind of iterative process in order for our programs to run that is going to come back to us as we talk about recursion. So that's maybe one thing to sort of keep in mind as we move ahead. All right, well done, Yanal. Thank you. All right, so with that warm-up done, let's talk about recursion and what recursion is. So this fun little image right here. So recursion is a programming technique where a function calls itself directly or indirectly to solve a problem. It breaks down a problem into smaller, more manageable parts, solving each part with a recursive call. This approach is powerful for solving complex problems that can be divided into similar subproblems like sorting, searching, and traversing structures like trees and graphs. So before we move on to these 3 rules of recursion, again, the idea is that our function is calling itself to get to some kind of output at the very end. What you all can imagine, maybe right off the bat, and based on this warm-up, is that if you just had a function that kept calling itself and no way for it to ever to stop, you would end up in an infinite loop. So as we'll see, there are a lot of similarities between recursion and iteration. And in fact, recursion is just another way to iterate. It's like learning just a new way of iterating through content. All right, so the 3 rules of recursion are this. So a recursive algorithm must have a base case. So a base case is some condition under which the recursion stops. This prevents the recursion from continuing indefinitely. In our while loop from the warm-up, right, we had a case where the situation would stop. That was where index was less than the names.length array. So we need to be thinking in a recursive function of something similar to that, some situation where we're going to stop having the function call itself. Recursive algorithm must change its state and move toward the base case. So change state, this usually involves modifying parameters or processing smaller subsets of the problem. So again, like with our previous example with the loop, the thing that was missing was we needed some way for our index variable to change, right? It needed to increase in size, and we had not done that. And then finally, a recursive algorithm must call itself recursively. Recursive call, the algorithm continues to solve smaller and smaller instances until reaching the base case. So this is a bit of a sort of the definitions in the name here. Recursive algorithms must call themselves. That's what recursion means here. All right, that is the idea behind recursion. Let's go ahead and talk. We're going to work our way up to a recursive challenge, and we'll look at some code and how that works to make it a bit more solid. Before we get there, let's go ahead and take a look at this following code, which adds up all the numbers within an array. So you all have definitely seen code like this a number of times. This is kind of a typical accumulator pattern where we're accumulating up to a single value. So you can see here we have a variable called numbers that points towards an array of 4 numbers, all of them even, 2, 4, 6, 8. We then have a result variable. Notice that the numbers array is defined with const, whereas the result variable is defined with let. So that means we can reassign the result variable. We then have our typical for loop, which allows us to basically loop up with indexes that will allow us to access each element at the array. Then we're going to define a new variable called number that's just accessing that individual item, right? So we'll access 2, 4, 6, and 8. And then we'll add each of those numbers to our result. So the goal of this small little code snippet is just to add all these numbers together. All right, and so while this code may seem straightforward, let's consider the actual process that the computer follows. So again, we might describe this as simply adding up all the numbers in the array, but that's sort of our human language of how to describe this. A more precise description might be something like This program starts with a result variable initialized to 0 and then adds each number from the array to this result one by one until there are no more numbers left. So we're saying we start with 0, we're adding numbers until we get to the end of that list. Just another way to say the same thing. The idea here, we're just adding a bit of precision. If we wanted to express this algorithm in terms of sort of the arithmetic, just the adding of what's happening, it might look something like this. Now, all these parentheses feels like a lot, right? We don't really need this as humans to be able to read through how we would add all these numbers. But the idea here is that we're breaking down this larger problem of 0 plus 2 plus 4 plus 6 plus 8 into these smaller subproblems that actually look quite similar. So we have a subproblem here of 0 plus 2, a subproblem here of the result of 0 plus 2 plus 4, a subprocess here of the result of 0 plus 2 plus 4 altogether plus 6, so on and so forth. So each of these subproblems has no more than 2 numbers added at a time. So we've defined something really specific and small in terms of how to sort of think about this function and the algorithm that is getting enacted here. So in this step, we're just stepping through, or in this part of the lesson right here, we're just stepping through each process. So we can see we add 0 and 2, sum replaces that operation. And so then we end up with just 2 numbers getting added. We then add those 2 numbers. The result of that allows us to add another 2 numbers. The result of that allows us to add another 2 numbers, et cetera, until we have no more numbers left to add. I know this seems like super verbose, right? We're just talking about adding up some numbers. This isn't complicated, but notice some of the different qualities here that we're trying to pull out that are similar to what we just talked about with recursion. So if we loop back over here, we have this idea of a base case, must change its state, and must call itself. So the idea of calling itself, start at the bottom here, is that we have some process that we're repeatedly doing. And the process we're repeatedly doing here is adding 2 numbers. In terms of the progress made towards itself, right, the idea is that we have this longer list of numbers, and then we're slowly decreasing the numbers that are getting added, or rather the overall list of numbers, maybe I should say, and adding each one together. And in the base case, the place where it stops, right, is where we actually have just 1 number left, or just the sum total. There are no more numbers to add overall. So we're starting to see how this can sort of apply to recursion. All right, and we're going to walk through an example with some code, but just as a quick note for this kind of example, with recursion, not always the case, but often the case, how you might originally think of things, you are going to think of it backwards, or rather just sort of flip the order here. So for recursion, in terms of what we just talked about, right, this is how we would add it as humans, right? We add left to right and just sort of add in some of those numbers. Recursion will work is that we'll do the exact same thing. We're just going to do it from the very end and putting that 0, that base case at the very end. So here we're saying, okay, we're going to add 8 plus 0, and then 6 plus 8, 4 plus the result of 6 plus 8, et cetera, et cetera. So just keep that in mind as we move over into this code example. We're going to maybe just flip the regular order of operations that we would typically follow. All right, that was a lot of yammering for me. Let's look at some code. We can actually get an example of what this is. So we're going to really slowly walk through this pretty simple code example that we've just talked through and work it up to a recursive solution. We already have seen how we can do that with iteration, right, with a regular for loop. So we're just going to kind of translate it to a recursive solution. So again, we have our 3 basic rules here. A recursive algorithm must have a base case, a recursive algorithm must change its state in between the base case, and a recursive algorithm must call itself recursively. So we're going to start by focusing on just the first rule. Recursive algorithm must have a base case. So a base case refers to a situation where the algorithm knows it cannot or should not go any further. In our example, the base case is when there are no numbers remaining, right? That's what we were talking about. We've added up all the numbers. There's nothing left to do. So if we wanted to represent that in code, we might write something like this. I'll make this a little bit bigger over here. Let me know if you all cannot see that well enough. Hopefully that's big enough. So writing this code is not super interesting. We're still building that sum function that we've just been looking at. We're just thinking of the base case here. The actual code that we need is just like this line and the return statement. We just have a couple console logs around here to help us start to see kind of what's happening. But basically, our base case is saying, okay, we don't have any numbers left, then we're done. And we're going to, right now, just return. We're not really sure what we need to return just yet, but right now we'll just return. So if I run this code, we can see that the logs do come out. So it says numbers array here, and then it says hit the base case, and this is our return value, which is undefined. We can see down here, the input is an empty array. The total is just the invocation of our sum function, and then we log out the result there. All right. So not too bad, right? Right now we're just saying, hey, numbers is empty. Go ahead and just return, and then we'll figure out what to do with that later. All right, now start to get a little more interesting in terms of our recursive function. So remember the second step, a recursive algorithm must change its state and move toward the base case. That move toward, again, is that whatever the base case is, we want to take some action that will lead us in that direction. So what would it mean to move toward the base case? Each time the process progresses, we need to access the next number in the array and add it to the previous result. We then must progress to the next number in the array. So we kind of have that over here. Someone help remind me, what is this line of code doing? This line of code on line 9. This is using a technique we learned a while back now. What is this line of code doing? Line 9. Well, good. I can wait. I got some tea right before we started. So I'm happy to just hang. We all think about it. So on line 9, what's going on? All right, so Joseph says it's adding numbers into an array of number. All right, other thoughts? Yeah, Tatiana says array destructuring. Excellent, y'all. Yeah. Yeah, so in this case, we're not actually adding any new values into our numbers array. We're actually we're pulling the first value within that array. So I'll go ahead and I'm going to open up a node over here. Remember, this is just where you can write some code. So let's just make a new array. We'll say names. We'll add my name. We'll add Joseph's name, and we'll add Tatiana. All right, so remember, we have a lot of different ways we can access values and change values within an array. So if I wanted to access the first value in an array, I can say names at 0. If I wanted to just pull and get access to that first name, I could do something like this, right? This would give me access to the value within that array at the first position, which is index 0. However, I can also do that by doing something like array destructuring. What that looks like, I guess actually I should say first. That looks like is something like this. What the syntax is saying is, okay, we're expecting an array on the right-hand side of this equal sign. For the first item that's in here, go ahead and grab out the first name within that array. So our names array stays the same, but the first variable name gets access to that first one. And remember too, that you can do this with multiple elements in the array. So I could say something like, I'm using all the words I want to use. My name, and then I could say fellow name equals names. So it's going to grab the first item from the array and assign it to the variable my name, and grab the second element in the array and assign that to the variable fellow name, just because of the order right here, right? So if we take a look at those individual variables, we will indeed see that we have access to them, and we still have the names array, right? It's just stayed as is. The last little step here that I just want to cover, goodness, a bunch of variable names for the exact same thing. So I'll say my other name, and we can also use this operator to grab what? What does the three dots do? What do the three dots here do? I know it's been a bit. It's been a bit since I looked at that. What do these three dots do in JavaScript? What do y'all think? Yeah, so sorry says it's the spread operator for sure. So that's one of the words for it is the spread operator. Allows us to spread apart different values. There's one other term we used for it as well. I have to remember the other term for it. All right, no worries. So the three dots depends on the context in which you're using them. So in this context, we're defining a new variable on the left-hand side within our array destructuring using our three dots. And instead of spreading values apart, it's going to grab the rest of the values. This is called the spread rest operator. So the rest of the values in our names array doing dot, 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 some name, that'll allow us to assign a variable that takes everything but the other values that we've just defined. So if I say something like dot, 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 fellows, oh gosh, and I spell my variable names correctly. My other name is still the first item, right? So I'm still grabbing that first item out. If I type in fellows here, that's grabbing everyone else, all the rest of the values within that array. So this is pretty useful. This allows us to maybe pluck out the first couple values and then grab everything else in the array and do something else with it. And of course, we still haven't changed names in any way, so we still have access to that variable as well. So these are some useful tools. We've covered this before, but it's been a bit. And we've all been doing lots of other stuff, right? We've been doing React and different algorithms. So just as a reminder, we have these tools at our disposal. All right, excellent. So let's clear this out. Let's get back to our code here. So getting back to recursion here, we again have our base case. We're not entirely sure what to do with it just yet, but we know that we want to keep running this code until we reach the situation where we have no more numbers left. In terms of moving towards the base case, one of the first things we want to do in terms of moving towards the result of this function is to grab out that first value. So we can do this with array destructuring. So looking at this code, our input here is just an array with one number. We pass that into sum, and then we'll log out the result. So this code should just give us the number 2. And so the reason it does that, right, is our numbers array is just an element, or sorry, an array with a single element. We have the first item in there, which happens to be the only item. We're then logging it out. That's what's happening right here. And then we return that value. So we're getting access to the individual number, but we're not actually really like progressing just yet. So let's make a little bit of progress towards that. All right, so in this next example, we're further along, not quite yet at our iterative step. But the thing we've added is our rest operator. We've said dot, 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 remaining equals numbers. And then we're going to log both of these out. Notice that our numbers array is a little bit larger now. So based on what we just talked about, what should the value of number be? And what should the value of the remaining variable be? What will those values be based on this input that we see in here? What's going to be the value of number and what's going to be the value of the remaining variable? Oh, several people are typing. This is the best way to start a Monday, y'all. It makes me warm, makes me feel good inside. All right, so what's going to be number and what's going to be remaining? Give everyone a moment to think through. Yeah, excellent, Tatiana. Sorry, appreciate it. Joseph, appreciate it. Yeah, so our current number that we're going to have access to is the value 2, whereas the remaining array is going to be 468. And just important to, maybe this is obvious, but just important to know here, the data types of these variables are different, right? So number is giving us access to the value within, and remaining is giving us access to an array of all the other values. So we have two different data types here, right? We have the individual value and the array of those values. Okay, so far, this function is super lame. It does not sum anything. There's not a lot going on, right? We've kind of just set up our work here. We have the idea of a base case. We kind of have the idea of making progress towards a number. We're accessing different parts of it. Let's take a look at how we can use this code to really make this a recursive function. So the third step is that a recursive algorithm must call itself recursively. So let's take a look at the one change that's happened here is that we are returning the call of the same function we've just defined. So right here, right, we've defined the function as the word sum, right? So that's our function name is sum. We then check, hey, is there no items in here? If so, we're going to do something. Otherwise, get access to that first number and then grab all the remaining values. Down here in the return statement, we're calling sum with remaining, right? With remaining, which is an array. So I want y'all just take a second, just take 20 seconds or think to yourself, like, what do I think is going to happen when I run this code? Think of what the outputs might be, think of what might happen. If there's going to be like, if they were going to stop, what do you all think? Welcome to share out or just kind of think about it, anticipate. What do we think is going to happen here, right? Because we're calling this function, it's calling itself, right? All right, let's take a look here. I'll give you a second to look at this output. You're welcome, of course, to run it on your own side. You'll probably see it a little bit better there as well. Yeah, excellent, Tatiana. I think that's actually a really good explanation, right? We're going to, and we can see from the output here, we keep calling this function. And each time the current number gets moved along. So we start at 2, then we go to 4, then we go to 6, then we go to 8, then our function is done. And it's just pretty wild. When we look at each one of these little blocks of logs, we see a few things. First of all, we see exactly what Tatiana just shared, which is that the numbers move along in the array. We also can see that the initial numbers array and the remaining array starts to decrease in time, right? We're constantly pulling out one number and moving on with it. This last step right here, so take a look here. So at numbers array, once we've gotten to array at 8, we grab that remaining number. We still define remaining, but there's no other items left. So we get an empty array. We then pass that empty array back to our sum function, and then we hit our base case. There's no items left here, so we're just going to go ahead and return. We hit the base case. So some really good news here. We can see ourselves progressing. We can see ourselves following the rules of recursive functions that we're calling itself. It's moving progress forward, right? All that good stuff. However, we're missing a little bit, right? Right now, when this value is returned, we're not getting anything. We just get undefined, which is a little odd, right? You might expect to be getting something back because we're returning the sum of remaining. So what do y'all think? Why are we getting undefined right here? Why is this function returning undefined to us? Sure, Tatiana says because there's no number left. Yeah, so this is true, right? Because we don't have a number left, we're not getting anything returned. We've reached the end of the function. What line, though? I guess when we get undefined back from a function, what does that usually mean, right? Usually it means we don't have a return value. We haven't returned anything, but we do have a return value here, right? We said return some numbers. So what else could be the problem, or where else is the problem? What line of code is giving us this undefined? Yeah, excellent, Joseph. Thanks. Yeah, it's tricky, right? So this last step here, we're getting the undefined because of our line 6. We just say return. We don't say any return value. That's different. I might be jumping ahead here in the steps. We'll see what happens. But if I say something like return done, notice what we see instead down here. We see the word done. So this is the line that's actually getting returned in terms of the output of our function. This is the actual line here. So let's take a look at how we can combine all these different things together. All right, so we're doing all the things we need to do, but we're not really getting that value back. So we need to make a couple modifications here. The first thing we're going to do is instead of just returning nothing, we're going to go ahead and return 0. Remember long ago, back at the beginning of this lesson, hours ago, it may feel like, we had this example here of, let's get to this next page here. Yeah, we're adding all these numbers and we had 0 at the very end down here. The idea being when we wrote this code, we needed some way to add up these values. And so we said, okay, result equals 0, and then we'll just add the values to that. It's kind of our base case here. We are seeing that right here. We need to add that last final value of like, great, once you've done everything, here's just the number 0, and then go ahead and add everything else up after that. The second change is that we're adding the number we've just grabbed to the return result of our recursive call, to the return result of our recursive call. This is where I feel like it starts to go, wait, what's happening? It's getting like a little weird. We're accessing that number, and then whatever the return result is of that sum function that we're recursively calling, that's where we're adding it to. So if we run this code, first of all, we can skip down, we can see that we are indeed getting the value 20, which is what we want to get out of this. So it is indeed working. These are the two changes we need here. We need to better define our return statement in our base case, and then we're accessing that current number and adding it to our sum. Okay, this probably still feels a little bit magical, maybe. Maybe you're starting to see how this is coming together. This next view just adds a couple additional console.log statements. The last one here, or the part that's been broken down a bit, is we have some new code right here at the end. The rest is all the same. We're saying const result equals sum remaining. Then we're defining a new variable called total, which is number plus result. And then we're just logging out that statement. And then finally, we return total. So again, it's basically the same code. We've just kind of broken it down into a few different variables and added this console.log statement. So let's go ahead and run this code and take a look at how it's changed. So everything up here is basically the same, right? We see we're iterating through, we're accessing each of those individual values. The array size is decreasing overall. We hit that base case, and then we have all of these console log statements. All these console log statements are running. We can see here the addition that we talked about previously in our lesson. We add 8 to 0. Then we add 6 to the sum of 8 and 0. Then we add 4 to the sum of 6 and 8, which is 14. Then we add 2 to the sum of 4 and 14, which is 18. So notice we have the structure, we're adding just 2 different numbers at a time, the entire time. We are getting that sum back from each recursive call and adding it to the next one, just like that little image we had of all the parentheses, right? Adding all these various numbers. Joseph is asking, do we need the first return a statement? Yeah, we do. I'm assuming you mean this one, right here where it says return 0. Uh, in the next slide, we're going to play around with this, and I would love for you to try that out and see how it changes. I think that's one of the examples. So it's a good question, right? Because at this point, it kind of feels like, oh yeah, this code should do it, right? This code should do most of it. All right, I think I explained all this. Sometimes I just yammer. I just get so excited about recursion. All right, yeah, I think so. Everything here we just talked about, right? This is where a recursive call is. This is where we're adding up those values, and then we return that value. A question for you all. So why is it that all of these console log statements are at the very end? What do you think? Because when you look at the order of this code, right, we can see, okay, current number, remaining array, we see numbers array up here, right? That's the console log statements for each one of these little blocks right here, these 3 lines. But all of these console logs where it says adding number and result are all at the end down here. Can anyone think of why that is? Just in terms of the order of operations that happen here. Maybe stump you on this one. Yeah, this feels kind of tricky. Because what we're looking at with the output, when we look at this output from here, we're seeing the order in which different lines of code are run in our program. And so what this output on the right is telling us is it runs these 3 lines of code, this one, and this one, multiple times, and this line of code once before it ever runs this line of code. That's the output we're seeing. Right. So that's how the program is running. It is not running this line of code. But I think as humans looking at this and having coded for a bit, it might feel a bit odd because when we look at this function, we can see, okay, but we have our different console logs of like this one. We have this one, it's within a condition, right? So we know that it might not run every single time, but we have a certain order here. And this feels like it's kind of running out of order, perhaps. All right, we'll get to why this is in just a bit then. Let's go ahead and take a moment to, we're going to do it right now before playing around. Great. All right, so to better understand this, let's go ahead and use this tool called Python Tutor. So even though it's called Python Tutor, can indeed use JavaScript with it as well. So I'll step through what we're going to do right now. Would love for you all to follow along here. I'm gonna give you just a couple minutes to kind of like play around a bit with the tool, and then we'll come back and I'll explain what we're seeing in Python Tutor. So to use Python Tutor, you can open it up, click on that link. Oh, mine went immediately to JavaScript. You might not have this view. Your view might look like this. Okay. If you get to a page like this, that's all good. Just go ahead and press JavaScript right here. That'll bring you to the right spot. And then what you're going to do is just come over here. We can just copy all of this code and just paste it in here. And then you're going to press the Visualize Execution button. So I'll give you all a second to do that. What this tool does is it allows us to run our code, and it's going to help us visualize what's happening at each stage of the code. So it gives us insight into the overall scope of what's happening within the function. So for example, what variable names are called, or what they're assigned to rather. It also gives us the output, so we can see if anything gets logged out, what that log is. And I'll pause there. So I'll give you all just a few seconds to open this up on your own. Again, copy and paste in that code, and then get to this page where we have visualize execution. Right, we'll give you all just another 15 seconds or so to hopefully get to this same spot on your own machines. Okay. All right, so what I really love about this tool is that we get so much information and we can like really slowly step through our code to really better understand it. So what we're seeing on our page right now is ads on the right. Great, we can visually ignore this. Fantastic. On the left, we're taking a look at the code that we copied in. This little arrow is showing us where the program is in its execution. So what we see here is that when this code starts running, the first line of code that actually gets run is this line 18. This makes sense. I know maybe it feels like, why isn't it all the way up here? Our function gets defined, but functions don't actually get run, right? They don't actually get executed until we actually call that function. So the first thing that happens is we define a new numbers array 2, 4, 6, 8. That's the first line that's getting run. When the program loads, it gets access to any global variables that are within the program. So the only global variable it has access to right now is sum. Maybe that doesn't quite make sense, but remember when we are defining our functions, we're giving it that name. So it is saying on the right over here that as part of the global scope, we have access to the sum word, the sum variable, which its value is this entire function. So nothing new here. This is just a way of sort of showing that the word sum is going to point to this function when we call it. All right, that's the first line of code here. We then move on to line 19. At this step, what we're doing is we're saying const total equals some numbers. Notice right here, we're accessing the numbers array. Actually, what I should say is, let me see this down here, line that just executed. So once line 18 is done, this is the state of the program. That's a better way for me to say this, is that we still have access to our sum variable, and we have a numbers variable that is pointing towards this array. And we can see that represented here. Our next line of code to execute is this one where we are going to call total. That's going to equal the sum of our numbers, our first invocation of that function. All right, at this point, when we invoke this function, you'll see our program, the little red line, moves up to our function definition. So the next line of code to be run is the first line of code within our function definition. On the right over here, notice we have, it says here frames, and the sum scope has a bunch of variables defined within it. And we then see numbers is assigned to this exact same array. Notice actually here how the arrow is pointing towards the same thing. That's because these are actually pointing towards the same thing in memory. All right. And then we have a bunch of undefined values right here for some variables that are coming up within this function. Does it remind anyone of anything that we did last week? I had this whole like digression. It was like blah blah blah. You need to use this really cool tool and like how how to describe it. And I'm sure you all were like, what is this guy going on about? This looks a little bit like a scope diagram, right? This looks a little bit like a scope diagram, and that we have our variables over here, and we're going to be tracking what the value is at any given moment on the right over here. So that's what we're looking at here. We are accessing the scope for this function call, this invocation of our sum function. All right, so let's step through a few lines of code. So this line of code runs. We see our output up here, 2, 4, 6, 8. That's our numbers array. We then get to our if statement here of numbers.length equals 0. We can see that the numbers array has more than 0 items in it. So we will skip past this entire block of code. So we can see up here, this is the line that just ran. We moved over it because that case is not true. That condition fails. We then are going to run this line where we're defining number and remaining. We move forward on that. Oh, this will work. There we go. We see number is set equal to 2. That's the first item of that array. And remaining is set equal to 4, 6, 8. Right, so we saw this in our code example when we've console logged stuff out. This hopefully doesn't feel too surprising. We're then going to step over, and we see here this line just ran current number. And this next console log line of 4, 6, 8. So this is what we were looking at before. And here's where it gets interesting. So far we're looking at the scope of sum, our global scope. We have our code over here. It's running through the first invocation of this function. When I run this line of const result equals sum remaining, take a look at where we head and what happens next. So result is still undefined, right? We did just run this code, but this line of code is not done executing yet. Gesundheit, Tatiana. So this line of code is not done executing just yet. So what happens is that line is executing, and when sum is executing, we head back up to the top of our sum function. So notice we didn't even get down to these lines of code down here, right? We didn't even get down here. What is this new thing we're looking at? We're looking at a new invocation of sum with its own scope with a smaller array. What is that smaller array coming from? That is remaining, right? And we can see that up here, which is really cool. We can see that in this first invocation of sum, that points towards the same array that is passed into our next invocation of sum. All right, let me pause here. Starting to get a little hairy. Any questions on this so far? Any questions on just what we're looking at? Or maybe like what any of this is representing? It's a lot of output here. There's a lot of things on the page, so no worries if something feels a little confusing. All right, feeling good, or at least hanging in there, sort of white knuckling it, being like, I think I'm holding on. I think I got it. All right, we got no questions for now. Seems okay. Just a couple other folks typing. I'll just give you all a second. All right, seems like it's landing for at least a few of you. Great. All right, excellent. So at this point, we're at a second invocation of sum. We have access to our array, and then we're going to run through our function again. All right, we step through. Nope, we have numbers in our array. It's not equal to 0 just yet. We define our number variable within this new scope. We define a remaining variable within this new scope, and we get access to this slightly smaller array. We blog out a few values up here, and then we get to the line where we call sum again. We call sum again, and notice that again, the input for the next invocation of sum is the same as remaining from that previous iteration. So let me give you all a few minutes to go ahead and play around with this. You can just drag this around to see kind of what's happening at each individual step. You can press next as I've been doing or jump between. Just want to give you all sort of a minute or two to play around with this. I want you all to go back to the initial question we were talking about before of why is it that this line 14, that's all going to happen at the very end, right? Why is it that that's happening? Oh, even cooler. Yeah, I forgot about this. So if you click on this line, it'll show you when the line of code gets executed, which is pretty neat. So we can see here, right, that this is only getting run later in the program. All right, I'll just put 2 minutes up on a timer here. right, that was a couple minutes. Hopefully you all had some fun clicking through this and seeing how it works. Joseph, thank you for that explanation. Yeah, so Joseph says, so the reason we're not getting this line of code running, or rather, maybe to put another way, why this line of code only runs at the very end of all these other steps, is because the sum remaining is calling itself. That is going back to the beginning of the code until the base condition of the statement, excuse me, is met before it progresses. So exactly that, right? Whenever we're going back to the sum execution, we're stepping back to the very beginning of the function, or never actually getting here. So what happens is that first invocation of sum gets called. We run through some code. We get to the second invocation of sum, and then all the remaining code that we need to run gets paused until that subsequent execution of sum is done. So we're running sum multiple times, and each one is like, okay, before I move forward, I need this next sum to figure out what's going on. Once it talks to me, it shares back its result, then I can continue. So let's step through and see how this works. So I'm going to run through a few more steps here, just kind of quickly. So we can see we run through a sum invocation again, this time with 6 and 8. We get a remaining array, which is 8. And now we're at the last step here where we're just accessing 8. So notice here, remaining is an empty array. Checks out, right? We've gone through, we've accessed 8. At this point in the code, oh, there's our little line. Oh, I'm so sorry. The little line up here just kind of disappeared. Perhaps that was from me clicking around on stuff. I think that's okay. We can still talk through it. So at this point, we've defined remaining, right? That's happening at this line right here. We're then going to get a couple additional logs out. We see that here as a remaining array. And then we're going to call const result with sum remaining, which again is an empty array. So we get this last one down here. Notice it's pointing towards the same idea, an empty array. So now when we start to step forward, we're actually going to hit this base case here. So we see our console log statement numbers array. And we can see it hits the base case. Then we're going to go ahead and return 0. And down here, we'll see all these other variables are just left undefined. When we return the value of 0, this value is going to come back up to this previous invocation of sum. So notice how, sorry, let me step back here. Result is still undefined because it's waiting on the next execution of sum. We see that all the way up this chain. When this value gets returned, result is 0. And that means we can now continue with the rest of our function call. So we got number plus result here, right? We run that. That's our total. That's our total variable. It gets defined. We're going to get a new log out that says adding 8 and 0. This is after we've done all this other logging work. And then we return total. That total value, right, is 8. So what we should see is this value come up here to our result. We do indeed see that. So now we have 6 plus 8. We run through that code to get 14. And then go ahead and return 14 back up to the previous sum call. Get result as 14. We add those values. We get 18. Take the next few steps. We return back 18. 18 is up here now. We finish out our final steps here to return 20. That's the total value we get back right here at this line. And then we console log out 20. So notice how this worked, right? We did all the work up front, and then the final steps were just adding all of these values together. And again, the process here with recursion is that we set up our function call, it calls itself, and everything after that is waiting until that subsequent function call completes. That subsequent function call does the same thing, does the same thing, does the same thing, recursively steps all the way to the very end until we hit that base case, in which case we start to work our way back up, right? That gets returned, that gets returned, that gets returned, that gets returned until we end up back at our initial call. So we're setting up a chain of events. And our function execution will pause at different points, particularly whenever we call the function itself. And it's waiting, it's holding on until that value gets resolved. The last little thing I'll say on this bit is it this page? Which one? Oh, dang it. Which one was that little image? That's why, by software development standards, this is mildly funny. Because the idea, right, is that we have our first invocation here that calls our second invocation, that calls our third invocation, so on and so forth. So that's the idea of recursion, is recalling itself. It's sending out that call, running through the code, and walking its way back until we have a final sum. Okay, let's see here. I think this is the next one. Yeah. Okay. So we've seen that now with some code. I want to get back to sort of the one of the questions that Joseph asked earlier of do we need the return statement and sort of exploring this a little bit. So we've seen how it works. We've run through how to write the code. We've run through with Python Tutor how we get these different frames of scope at each step. We'll just there's just two tasks here just to try out, just to see how it changes the overall function. So first of all, I want you all to try and change the base case so that instead of returning 0, you return just this empty string. Think about how that might affect the overall output, and then go ahead and run the code and see if your expectation was correct. And then try removing that base case. And this is essentially, I think, what you were asking, Joseph, like if we just return or remove this return statement, what happens? So let me give you all a minute or two to try that, and then we'll come back and discuss. So what happens if we change the base case? What happens if we remove the base case? We'll put 90 seconds up here. Mm-hmm. All right, excellent. I see, I see. Cool. So let's talk through what happens when we make some of these changes here. So our first suggested change here is to return just these strings, right? Let's think about what we expect to happen here. I think what we would expect to happen, right, is that we're going to do some type coercion here. And if you remember that from early days of JavaScript, right, we're going to be adding a string to a number. That step is going to happen somewhere around here. And so we'll end up adding the numbers into this string. So we take a run here. Yes, a little silly, right? So here what we're saying is we're adding 8 and this empty string. That's going to convert 8 into a string itself. That's the value that's getting added right here. So we add 6 and 8 as a string. That does more type coercion, right? We're just adding onto this. That's why we end up with 2, 4, 6, 8. You can see this a little bit more clearly in terms of the what do I want to say? The output, like the colors that show out here. So if I just add a couple other commas in here, what we should see if we run this code, right? We're seeing like, this is the actual number. Again, the fact that we have a different color here is just kind of just a feature of our terminal editor here. We can see this is a number, whereas this is a string. And so we can see that type coercion happening. All right, excellent. So what's important there to remember is that thinking about what the base case is pretty important. You want to think of what data type you need as part of your base case or what you're going to be working with in order to figure out sort of what that base case should be. I would also add, though, actually, adding something like return empty string or just returning and add some console logs, particularly when you're trying to figure out a problem using recursion. It's actually a nice way to kind of see the code build up. So that can be sort of a nice trick as well to kind of see what's happening. If we remove the base case, if we remove the base case altogether, and so the suggestion here is just to comment out this line, and Tatiana, thanks for sharing that. And we run this. Oh, goodness. All right, we end up with a lot of output here. Actually, I wonder if I can even scroll to the top of this. Maybe not. It might just be too far up. Somewhere at the top here, there should be some lines of code that show what we've seen before, right? Where it has the entire array and starts to count down. But then we just keep on going. So I'll go ahead and just clear that. We can rerun. The error we get is interesting. So it says maximum call stack size exceeded, or range error. I guess actually I don't know if this is the exact same error that comes up with an infinite loop, but this is the idea, is that we're essentially hitting an infinite loop here. The call stack size exceeded. What under the hood is happening is JavaScript is for each function scope setting up its own little call, and the idea is that each of these calls gets stacked onto one another. The last part of that stack, when we have a successful base case, that's what gets evaluated, and then we work our way backwards, right? We pop things off the stack until we get back to the initial case. If you looked at the website Stack Overflow, that's what this is, right? That's what we're talking about here. So because we don't have a successful base case, it just keeps adding on to the stack, and eventually that call stack size, whatever that is, which is often dependent on the language or the computer, the website that's running our code, it sort of just says, nope, I'm good. I can't run this anymore. So we're just going to fail out here. So not including a proper base case might lead to this kind of error. And if you see this, that probably means you're not really hitting the base case when you need to be hitting the base case. So those are a couple things that could happen. All right, and now just taking a step back here, just to look at our code. We had a lot of console logs in here, which can sometimes obfuscate what it is we're looking at, make it a little bit harder to see. But this is actually just the code. It's just this, just a few lines of code here for a recursive sum function. So remember, we have three rules. We have a recursive algorithm must have a base case. That's happening right here, this if statement and this return 0. Recursive algorithm must change its state and move toward the base case. And so that's happening with these couple of lines, right? We're always taking out a number and calling again, but with an array that is a little bit smaller. And recursive algorithm must call itself recursively. That's happening right here. And so that's where we're making the call on sum, continuing to make that call until we hit the base case. So a couple of other sort of tips, right? Remember, it's sometimes most effective to think of your problem backwards with working with recursion. So another way you might want to start with the end in mind. Thinking of the base case first can be helpful when challenged to solve a problem with recursion. And when a function calls itself, each invocation of the function receives its own scope. We saw that with Python tutor, right, where each of the invocations had its own version of the variable, its own values. And those are going to keep getting called until we get to the very end, our base case, and then work our way back up. Let me pause here. Any questions on any of this so far? This is the idea. Pretty much the rest of this lesson is us playing around with this and trying to solidify the idea. But any questions about how this works? All right, cool. Hopefully this is, at the very least, seeming kind of interesting, if not a little bit weird, right, that we can do this. I'll say this is a pretty common, this should be accessible in most programming languages. I can't think of anything why it wouldn't be the case unless it was explicitly disallowed, but you can indeed run this all over the place. So even though we're doing it in JavaScript, this is applicable to other programming languages. All right, so we talked about what it is. We saw some examples, both in code and talking through it. Well, why though? Why are we doing this, right? Why would we need this at all? So what we saw is we rebuilt a sum function that was using a for loop using recursion. So interesting, neat. We had to learn a little about the language, but why would you ever use it? So recursion is often described as sometimes leading to more elegant or more readable code. That may feel a surprise right now, but stick with me for a moment. So when a function calls itself, it signifies that the function is breaking down a problem into smaller, more manageable, repeatable steps. This is to say that you don't have to use recursion. In general, any recursive problem can be solved with iteration and vice versa. It might be a bit awkward, though, to do one over the other. So recursion and iteration are both tools that allow you to progress through a problem, to iterate through a collection, an object, an array, take a number of steps, right? The choice depends on the specific problem and the context. In general, you can sort of keep in mind, first of all, what's more readable. Sometimes you'll come across situations, and we'll look at a few, particularly tomorrow with merge sort. We'll see an example where I think there's a good use case that recursion actually makes it easier to understand. Recursive functions can be more straightforward and easier to understand when dealing with problems that naturally fit the recursive approach, such as traversing tree structures or generating combinations and permutations. So sometimes just using a recursive function, it just kind of makes sense because you have a big problem and you're breaking it down into smaller steps. So it can actually be easier to think about the problem when you have this tool of recursion available to you. However, recursive calls involve additional overhead due to maintaining the call stacks. We actually just saw this break, right? So in some environments, this can lead to performance issues or stack overflow if the recursion depth is too high. So it's not actually, I think sometimes people think recursion is like somehow magically more powerful, or it's gonna solve your like efficiency problems. It's almost the opposite, right? Recursive calls can actually cause a problem in that we have a new kind of data structure we're working with under the hood that needs to get managed. However, in many cases, recursive solutions are considered more elegant as they can turn complex iterative loops into simpler declarative code. I think probably the best example here is just thinking about sometimes when it's pretty confusing, trying to follow, okay, I have a for loop here, I'm using the I variable. We have another for loop, I'm using J. I have a bunch of other variables happening around it. Sometimes that can just lead to kind of chunky and confusing code, trying to read through all these different steps that are being taken. Sometimes recursion can really help with that to just make it look a little bit easier on the eyes. Ultimately, unless you're getting asked to, for example, like solve a problem using recursion for like a coding challenge, you really have the option to do recursion or iteration either way. So just some of the ways in which they are different. So the approach to problem solving, so iteration solves problems by repeating a block of code, whereas recursion solves problems by calling a function within itself to repeat operations. That's kind of the base difference between these two things. As I talked about memory usage, the recursive calls adds to the call stack, each call having its execution context, whereas iteration doesn't significantly increase stack usage since it uses a single block of code repeatedly. Base case versus termination condition. So this is just kind of a slightly different way of thinking about when does this looping end, right? So recursion requires a base case while iteration uses that termination condition. That's something like I is less than the array.length, right? Both very similar ideas, ultimately. And then just the main thing is just readability versus performance. And so we'll look at some examples today and in the future where recursion can just kind of read a bit better than the iterative option. All right. So we're going to do, let's see here. We're going to do one example here, and then we'll go over to a lab. Yeah, I think let's do this now, and we'll take our break as scheduled. Hopefully I haven't overfilled y'all's cups too much. You can still hold on to the information. So we're just going to look through one more example here with recursion before taking a break. All right, so with this one, we'll basically be doing this together. I'll be stepping through it, but we have less of the console log statements and less of the hand holding here. So we have this wild data structure where we have an array of numbers that have arrays in them, that have numbers that have arrays in them, that have numbers that have arrays in them. It's complicated. You may look at this and go like, oh, that'll never happen, but you'd be surprised how bad some data can get based on a variety of factors. So either way, the only two data types we're working with within this data variable are arrays and numbers. That's it. So the following is true about the data set. Every element in the array is either another array or a number, and no array is empty. That's important as well. So our goal is going to be to return an array of all the numbers using recursion. We can also use iteration in this. We're just trying to use the right tool at the right time, whatever it is. Our end result that we're trying to get to is this idea, right? So we're taking all these numbers out and we're trying to flatten the array. So we just have a list of numbers that we can work with as opposed to this really complex random structure. So that's the goal. All right, so one of the first things we can do for this, we're trying to find all these numbers, is let's start with just our regular iteration. We can see here, we have a for loop, nothing super exciting about this. Say I equals 0, I less than array.length, I plus plus. This array is the thing we're iterating over. How many elements does the outer array, this data array, have? How many elements does it have? I know it's a weird question because there's a lot of stuff inside. But think about it this way. Our outer array, our data array, has a certain number of elements. That's the indexes we're going to get. How many elements does this outer array have? Right, just says 2. Any thoughts? All right, one way we can find out is I'm just going to go ahead and run this code, and then we can grab the length of it, right? So we have our data array, it looks crazy, and then we can ask for the length. Yeah, so in this case it's 4, just like Omar said. So why, it looks like there's so many items in here, right? It looks wild. But remember, in terms of what each item is an array. How arrays work is that you just have some item separated by commas, right? And those items can be anything. It can be anything, including other arrays. So when we look at this data structure, we can see, and thankfully our terminal or our editor, excuse me, has a little bit of color coding here, so we can hopefully kind of match some of the brackets. We can see this yellow color for this. This is the array we're working with. We can see we have the value 11 here. The next element in that array is this entire array. This entire array has other arrays inside of it and numbers inside of it. And they're all mixed up, right? But that's just one element as far as the outer array is concerned. Same thing here and same thing here. So there's just 4 elements in this array. So when we run this code, what we can see is we run through, right now we're just looping over, we're grabbing that individual value at each element, and then we're just printing it out. So we can see each one of these elements. We see 11, we see this array with a whole bunch of stuff in it, this array with a whole bunch of stuff, and this array with a whole bunch of stuff. And then we have our return value, which is undefined. So right now we're working our way through, but as we're seeing, we can't get into those inner arrays right now. For me to put it another way, we've gotten access to the elements in the first array, the top level, but we haven't figured out how to dive deeper into the sub-levels of that array. So now I want to think through what's the base case. We have this situation where we need to run essentially this code of, okay, dive into the array, look around for numbers, dive into another array, look around for other numbers. Right? So what's the base case here? And the idea is that the base case is, in terms of our recursive function, its job is going to be to keep drilling down into the array. So if it's an array, we want to continue. If it's a number, that's the thing we want, right? We're good. So we can stop trying to dive deeper in any way. So that's going to be our base case. Is the thing we're looking at a number? And we see that with this code that's been added right here. We can see number is integer. whatever that value is? If so, right now we're just going to log out the value. Otherwise, we need to do something else. We need to somehow dive deeper into the array. So we run this code, we'll see we just print out 11, and then the function ends up returning, or it completes, right? And that's because for this array of 4 elements, even though we see a lot of nonsense in here, right? But this array of 4 elements, there's only one number. All the rest of this is arrays. Okay, so we've kind of figured out our base case here. We've said, okay, well, if the number's an integer, then that's a place to pause. We're good. If it's not an integer, remember the constraints we had from our initial sort of setup. The only other option is it's an array. So what are we going to do then? Well, if it's an array, then we can just call this function again. Because our idea is that when we call this function with an array, we want to grab all the numbers out of it, and then we dive deeper whenever there's an array. Let's go ahead and run this and kind of just see what happens. So we can see here, it actually does look like we are accessing all of the numbers. All of these numbers in order are getting logged out. It's pretty cool, right? That's kind of what we're trying to get at. We're trying to get closer to. We want to be able to access each one of those individual numbers. We're also getting a lot of these undefines. All these undefines. What do you all think this is from? Why do you think we're getting all of these undefines in here? What is that coming from? Either why do you think that's happening, or what line is triggering it? What do you all think? All right, I'll give you a few more seconds to think through. Why do we keep getting undefined? I got a couple ideas here. Sorry, it says no return. It just says because the remaining are arrays and last is an empty array. Uh, I I think sorry is on to the idea. I think just if you're on to something here, if like we've iterated through as far as we can, so that is true. Um, yeah, sorry, you said it with a question mark, but you're totally right. I feel like I'm a broken record here of like, have we returned? Are we returning anything? What do we return when the function doesn't have a return statement, right? So we're getting undefined because there's no return value in here. There's nothing getting returned anywhere. I think that's actually going to your point, Joseph, of like we dive into these arrays, we get to the number, and then we don't do anything with with it right at the moment. So if at the very end, we can sort of see a different result if at the end of this function, we just return something, right? We just say return end. If I rerun this, what we'll see is for each of those undefines, we're now seeing the string of end, right? So we do need to find, like, we need to think about now, what are we returning here? And this is pretty tricky because at this point we have access to our values. We're successfully recursively iterating through every single number, right? So that's great, but we don't have the thing we need, right? We don't actually have the return value here. So remind me, all, what are we trying to get out of this function? What data type are we trying to end up with? Are we trying to end up with a Boolean, a number, an array, an object? What data type are we trying to end up with at the end of this? It's not a string. It's not the string end. I feel confident in that. Yeah, Joseph's got it right. So we're trying to end up with an array. So somewhere in here, we need to start building an array that has all these different numbers. All right, so we have this next step here. So here we're saying, great, we need to build up an array. Let's go ahead and do that. On line 9, set a new variable called result, set the equal to an empty array. And then we're going to run our code. And regardless of the value, we're going to push, sorry, I should say regardless of the path, that's really what I mean to say. We're going to push that value into our array. Now, thinking about this from our recursive standpoint, this feels like it should work because if the value is an integer, we're going to push that into the array. Otherwise, we're going to recall this function, and eventually we should end up getting to a number, right? It's eventually what we should end up getting to. So we're able to push that value into an array. And then finally, we'll return result. All right. We run this code. This is our solution. It looks like we didn't do anything. It looks like we just returned the same value. But we did all this work. We did all this work within here. So why do you all think that is? What do you think the problem is with this code that we have right here, where we set up a new array, we then run through our recursive function, and then we return that array? What do you think the problem is here? All right, it's starting to feel tricky. We were just summing stuff, right? And just be like, all right, we could kind of sum and add some numbers. Now that we're working with a new data type, it's like, oh my God, what's happening? Why? Why is this going on? All right, so there's a couple of things we could do to move this function forward. But think about this. Part of our recursive function, right? Our rules for recursive functions that it has to call itself. What's happening every single time we call this number finder function? We're declaring a new array. So we declare a new array. Nice. We're going to capture all the numbers. And then we end up with number 11. Fantastic. And then we get to our array portion and we go, fantastic. Okay, let's go ahead and just call number finder again. Then we declare a new array. Then we go ahead and push in whatever values we find. Otherwise, we call it again. We start a new array again. So this result array is getting redeclared multiple times, and it's capturing each of these values. So it's interesting. We end up basically with the exact same thing we started with, even though our code is running. So something about this is not working, where we're defining result each and every time. Actually, I wasn't thinking of this before, but let me just try something here. This might don't hold it against me if this doesn't work. Cool. Even better. But interesting. So if we move result outside as like a global variable to our function, we actually feel it almost feels like a little bit closer. We're accessing each individual value. These circular references mean there's some circular call to itself or some other value in here. So a bit interesting. So the problem here is that we're continually redefining results. When you think about how do we pass the current context of what result is along to each subsequent call, right? So when I call number finder again and again and again, I want this one down below to still have access to or still know what that overall result variable is, so that when we push a value inside of it, we're not pushing it into some new array we've created. We're pushing it into that main result array, right? All the subsequent calls somehow need to have access to that same array up at the top. So that's what we're trying to kind of get at here. Okay, so we made a couple changes here to this code to get this to work. So let me go and just run this. We can see that this code does work. We have our solution over here. Nice. It's a flattened array. Everything's in order. This looks like this array could be ready to run a sorting algorithm on, even, perhaps, right? So let's look at some of the changes we made to get this to work. I'm going to highlight the first change here is that when we're pushing result, we're saying result.push number finder here. This isn't quite right, right? That was never going to be quite right because the idea is that we don't actually want to, we just want to push the numbers in. We only need to do that once. We're doing that right here at step 12. So the first thing we do is remove that result.push. So we're just calling number finder right here. That's our recursive call. The second thing we changed was up here and with the invocation of number finder. What is this? What is this all about in our function definition? What is happening here? We've added a new parameter called result. What's that equals empty array about? What is happening with that? What do y'all think? I know this is now from like, I want to say it's like 4 months ago. When we first talked about this, 3 or 4 months ago. Yeah, so just shares. Yeah, so we're initializing an empty array result to store our final array. Yeah, right. So we are initializing a value here. This is our default value for result. So if we call number finder without a second argument, and we do that down here on line 21, our function will create a new variable called result and set it equal to an empty array. On every subsequent run, if we pass in a result value inside of here, we will not initialize it to an empty array. So it's just our default value. What this allows us to do is allows us to pass down this array contextually to each subsequent call. So notice here for number finder, we're passing the value down. And that value is the immediate item, which could be a number, but could also be, in this case, it's going to be some kind of array. And then we pass down our current result, our context for our overall program running. So this means on a second or third run, the result array is going to be the array we get at the solution. And that's the thing we're pushing into. We're not creating a new one at each step of the process. So this gives us access to that same value. All right. It's a little tricky for sure. So let's go ahead and use Python Tutor. Go ahead and visualize this one more time. Let's take a look. So I'm going to step just a little bit in here. Whew. Take a look at this. First of all, here's our array. Look at this nonsense. This is the overall array. We can see we have the number 11, and then it's pointing towards another array, and that's pointing towards another array. And we have all these crazy values in here. So this is the overall data structure we're working with to the start. We start walking through this code. We can see the values increase here, and we're starting to move into our recursive calls. Let me actually back up here a tiny bit. All right, right to here. So on our first call through, so up here under result, and this is like hard to see here, just because of the amount of stuff that's on here. This is our result array. That is our default result array right here. Okay, step back just a little bit. Let me find where this would happen. Great. All right, so on this line, we're iterating through data. The first element is a number. Cool. Inside of here, we say number is integer value. It is indeed. So then the next line of code we'll run is result.push value. So this result value points towards this empty array right now. We then push that value inside, and we got 11. Fantastic. That's the first value we want. We step ahead a little bit. I'm just going to jump it around a little bit so we can start to see it change here. On our second call through, Notice we still have access to the same array, right? That's the result array right here. It still has access to this array. That's because we're passing it down on every single function call. Our current value within this function call, where we're at in this process, is this array of just 38 and 40. So it's looking at this right here. We can see that this array is not an integer, so we call number finder again. That jumps down here. Notice result is still pointing towards this array. So you're going to start to see a whole bunch of arrows pointing towards this array as our code starts to step through, drill into an array, pull out the numbers, drill into an array, et cetera, et cetera. The array we're working with is this array up here of just 38 and 40. Our first value in this sub call is 38, right? We're accessing that first item within that array. Fantastic. We go ahead and then push that value into the array. That shared array now has the number 11 and 38. So this result array is what's getting passed around in all these subsequent calls. And this is a somewhat common pattern, I would say, in these kind of recursive functions, is jumping up and down, or rather passing through sort of a result context, might be an object, an array, maybe it's a number, and optionally being able to pass that through at different points in order to pull up their values to have a final value that is the shape you want it. We keep stepping through here. We should see that we add that next number that we have, which is 40. Excellent. That invocation is done. Our array is done here. So we return that back. And then we jump back up and move on to the next stage of our process, where we start to work with the number 13. That's this value here. With that value, we're going to add that 13 down to our array that we're accessing. So jumping around here, we can sort of highlight this. We can see there's multiple places where we're pushing into our array. There's multiple points at which we are making a recursive call. And again, the idea is that each recursive call is happening whenever we reach an array. We then jump inside and try and look to see if there's any numbers we can access. And we're going to slowly start to build up this array down here. If we continue to step through, you'll see more arrows pointing towards it, right? You can see all of these arrows are pointing towards the same array as we step through. And as these invocations finish, the numbers slowly start to get added to the very end of this as it continues to deeply work its way through. So pretty wild, pretty wild. Let me pause here. Any questions on this? Any questions on this? In the first example of our recursive function, we saw a pretty typical pattern where we are like adding something and the recursive call happened and we use that return value to add it to the previous result. In this example, we're following all the same rules. Here, that return value of what we're getting from number finder is actually not as important as adding to this result up push. That's the actual step of our process, which is updating code within here. All right, no questions for take a break. All right. Imagine this last example. Y'all are filled up to the brim. That is a-okay. Let's go ahead and take our 10-minute break. We'll do that, and then we have a lab at the end. I'll give you all some time to work on the lab individually as we work through it, and then we can walk through a solution. Good. So let's start with our break. All right, y'all. All right, y'all. That was 10 minutes. Welcome back. Joel, do anything nice for yourself on your break? I'm gonna take a nice stretch or get ourselves a snack. Anything else enjoyable? just stared catatonically at the computer, going, "What? Recursion? What?" Thumbs up. All right, cool. Honestly, I get it. Sometimes you just gotta close your eyes and go, "Okay, all right, what's going on? What's going on in my life?" That's an okay break too. All right, let me go ahead and share my screen here. So here's our lab. We will go over this, but I do want to give you all some time to try and work on this on your own. We do have a bit of time, so that's going to work out just fine. So what we're looking at here is we have a list of customers. So I'm going to get this to the right screen size here. Cool. All right, so we have a list of customers. We have a function that's been defined up here. It says regular customers, customers, and count. And then we have the function body here, which is currently empty. Our customers array has 9 items within it. Each one represents an individual customer. They all have their own unique IDs. They have a name, and each one has a purchase count key with a purchase count key representing how many times they've purchased from whatever store this is. And the idea is that the regular customers function should return all the customers who have come a number of times, depending on the count. So for example, if you were to run this function of regular customers with the customers array and the value 5, you will want to return an array of all values where the purchase count is equal to or greater than the value 5. So we see 587, right? So that grabs Leah Watts, Amir Vanilla, and Alexandra Mitchell. So it's finding the folks who have purchased the most. If we had customers, comma 0, that would return everyone who's ever made a purchase, right? Everything greater than or equal to 0. So your goal is to find a solution without clicking that reveal answer that allows you to have this smaller array with just a few different people within it. And we want to return the array with the entire object, right? The entire object that represents that person. So we could do this by just using filter, but we're not practicing filter. We're practicing recursion. So I want you to think of how to do this using recursion. So a couple tips here. One, this is kind of is a combination. It's very similar to the last example that we looked at, this number finder one. So I think this could be a great example to look at to begin to sort of think about what you might need to do here. Also, it's important to say there are a couple different ways to solve this, even in using recursion. So if you start to work on something and it doesn't look exactly like what we did, that's okay. You still may be onto something. So it's not about finding like the perfect answer we're thinking of so much as just trying to get it to work. A couple other sort of there's things to know. So the data type we're trying to get back is an array. All right, it's an array. So keep in mind that for what your base case is, maybe what you're going to return, right? When I think about at the end of the day, we need an array in here. Also want to keep in mind that in terms of making progress, right, we'll need to go through every single one of these items, every single one of the customers here. Okay. I think those are all my tips. That's all I can think of here. So again, I think this final step with the code in here could be a good place to start. This could be a good place to start. Any questions on our lab? All right, cool. I'm gonna go ahead and I'll stop sharing. Let's say I spend like 15 minutes on this, or actually, I'll put up a timer up here for 15 minutes. If you get done, please do just share maybe your output or let us know in the chat, just so I can best gauge where folks are at. At the end of 15 minutes, I'll check in where folks are at. We might give you a few more minutes, or we can start to walk through the solution depending on where everyone is. So go ahead and give it a shot on your own. No worries. We'll talk through solution soon enough, but when you all just sort of have a bit of time to think through this on your own. All right, go ahead and get started. Or Tama, do you want to share your screen? You can put on music. Is that something you'd be interested in doing?
Yeah, I can do that.
Awesome. Thank you. In about 15 minutes. Thank you. Thanks for the music too. About 15 minutes. Looks like a few of you all have come up with solutions. Nice job. I think I'll go ahead and just start talking through this. But if you're still sort of finishing up your idea, you're welcome to try and finish that out. Uh, don't want to interrupt your process. Excellent, y'all. Real quick first, how was working through this? Did it feel approachable? Did looking at the examples help? What was your thought working on these? Were you surprised by anything? Let me know in chat. What do y'all think? Pretty straightforward, confusing. Is anyone getting a brain freeze, a headache from trying to think through functions calling themselves, calling themselves, calling themselves? All right, I see that several people are typing. Oof, makes me feel good. All right, Omar says, first three tries, nothing worked. Went back to the previous exercise and managed to get it to work. Nice. Excellent. Tatiana says, surprisingly easy to follow, even for my already fried brain. Hey, my brain's fried too, but great. I'm glad it was feeling good. Sorry, I mentioned the previous exercise helped. Perfect. Excellent. Yeah, I think what's nice about this challenge is there are actually a couple ways to figure this out. But with recursion, there really are just like kind of a few techniques to keep in mind. You can use that sort of carrying of the result, the context through, or you can follow sort of our first example of calling and adding to within the same steps. So lots of different ways to do it. If you are at a good spot, I would love for you to share your solutions in the chat. Sorry, thanks for sharing yours. It's pretty close to the solution that we have up here. So I'll walk through that one first. But of course, if other folks have different solutions, would love to see them. Again, there are a couple different ways I think you can do this. All right, let me share my screen. So here's the solution in the curriculum, but again, there are a few different ways to accomplish this task while still being recursive. So in this example, this is sort of the synthesis of the two previous examples we've seen. So we're still returning an array, but in this example, we're using some different syntax so that we don't have to pass through that result variable. Either way, it'll work, but just showing sort of some different ways of accomplishing this. So when we're solving this kind of problem, the first couple of questions to ask ourselves. So first of all, it's what's our end result? What data type do we need at the very end? Right. And in this case, we need an array. We want an array of a number of customers equal, between 0 and all of the customers, right? That's the potential scope of this. The other thing to think is, okay, how am I going to get to that base case? What's the actual like condition I'm working on? And in this case, I would say it's actually most similar to that first solution we went through of having to go through all the different numbers. Our base case here is just there's no more customers to go through. We've gone through all the customers, right? So those are the couple things that can help inform how we go about solving this problem. So we can see in the curriculum solution here, the base case they have here is if customers.length equals 0, go ahead and return just an empty array. So we'll get back to this returning an empty array. But hopefully this part, this condition, makes sense and matches with what we saw in that first example where we were summing up all the numbers. What we're saying is, okay, once I've gone through all the customers, that's when I'm done. That's when we need to start returning something and accumulating our total value. Moving on, so in the case where the customer's length is not 0, where there are still customers left, then we're going to do that step of pulling out the first one and then getting the rest, getting everything else. In this case, they've called it head and tail. So it's like the current thing we're working on and then all the rest, the tail of the customers. You can call it whatever you want. If it's, customer and rest, that works too. Remaining, that's a-okay. Once we have access to that, we're then going to check, is the purchase count greater than or equal to count? So this is the kind of filtering step that we're following to only include the correct customers within here, right? So hopefully you all, no matter what you're doing here, have something like this, because we'll need to do some kind of check to make sure that we are indeed grabbing just the customers we want, which is, in this case, is anyone who has a purchase count greater than or equal to the count itself. If that's not true, so it is if the customer's purchase count is less than the desired amount we're counting for, we move to this else scenario. I'm going to talk about this else scenario first, a little bit simpler. So here we're saying, okay, well, in that case, just return regular customers and go through all the rest of them, right, and pass down the count. So let's ignore line 8 right now, but the rest of this should hopefully look pretty similar to the first problem in that we're checking, hey, are we done with all the numbers? Are we done with all the customers? If so, we're returning something. We're grabbing the first item out of our list and then using a variable to represent the rest of the list, our tail. We're then doing our check. In this case, this is specific to us deciding whether or not we want that customer within our list. And if not, then we're just going to go ahead and recall our function. This is a recursive call, but this time with a slightly smaller array. Right. So this is the part passing tail in that eventually will end up with a customer's length that is less than or equal to 0. All right, so this line 8 is a little tricky. It's pretty neat though as well. So, oh gosh, who was it who was saying spread instead of rest? I forget now. I'm so sorry. Sorry, great. And so remember before, sorry, I was saying, oh, this is the spread operator, right? And that is true. It is also the rest operator. So in this case, we're using it as we're getting the rest of all the items. And in this case, we are going to spread all of the items. So what this is doing is constructing a new array. At the beginning of that array will be the current item we're working on if the purchase count is greater than or equal to count, right? So this is a saying, great, here's our array. We're going to add that item to it. And we're going to add all the rest of the items. This is saying is everything else we can find when we call this function invocation. So we're calling the function invocation here. Regardless of what happens within regular customers, we're always returning an array, right? We're always returning an array. So we're returning an array in the base case. If the purchase count is not greater than or equal to the count, we're going to return our function invocation, which will eventually return an array. And right here, we're returning an array as well. Let's remember how the spread operator works is if I had some array of, let's say like 1, 2, 3. Oops, let me do this correctly. Say numbers. If I spread numbers, let me say like 5, 6, 7, 8. You can see the resulting array is whatever I've put within the array and all the rest of the numbers not within an array, right? So if I do this exact same thing, but I just put in numbers, I end up with this nested array structure. So remember, spread allows us to spread that out so that each number comes one after another within the array. So this is the step at which we're constructing that final array. And so each step of the process, if it's included in here, then we're going to go ahead and grab it. We grab the current item, and then we just do our function invocation and sort of include it as part of our array. And yeah, either that will end up being another one of these arrays, right? We'll hit another situation where we have an array with a head that we're pulling back in, or it'll hit this base case. And if we spread nothing, nothing happens, right? We don't get any new array values. Cool, y'all. Any questions on this, or did anyone solve it a different way and wants to share in chat? There are a couple other ways we could do this for sure. Nice, awesome. Thanks, Joseph, for sharing that. Yes, that one, the example that Joseph has shared, you all can see in chat. Looks a little bit more similar to the second example here, but works very similarly, right? We're pushing in the individual value into that result array, and then returning a different step. It doesn't look like you're passing in the result array into regular customers, but you've gotten it figured out anyway. Because okay, I see what's happening. Because you have that for loop there. Perfect. Excellent, excellent. Nice job. All right. Thanks for sharing, Omar. Yeah, I got something that's pretty close to what I got. Excellent. Looks good. All right, well, I believe that is it for our lesson today. Yeah, there's no closing slide here. So just to recap here for recursion, just a couple things here. First of all, as a reminder, is it this slide? Oh, is it this next slide? It's step 0. Where are those rules? Right, here we go. All right, so for recursion, there are 3 rules to recursion, right? We have a recursive algorithm must have a base case, recursive algorithm must change its state and move toward the base case, and recursive algorithm must call itself recursively. As we've seen, there are a few different ways we can still write a recursive function that will look different, but still fit within recursion. We learned about how to call that function and add it to whatever the current value is. We saw that in the first example. In the second example, we saw how we could pass through something like a results array, a context array, a final array, whatever that is, or whatever value it is, to subsequent calls by setting a default value and depending on that value later on. And we saw some examples of how we can write something as a loop, like with the sum function, right? We can also write it recursively, depending on how we write it. So we were able to see a few examples of that. We also learned about when to use recursion or why we might use it. Again, in certain examples, it might just end up looking better or feeling a bit better. I think this is an example where, I don't know, an iterative solution would, I think, work just as fine, or using that filter, which is a nice named method and describes what we're doing. But there's something nice about this too. I think this can look okay. And as we'll see tomorrow with merge sort, there are certain situations where recursion can definitely, I think, just make more sense than trying to do the iterative approach. Recursion can be used when we're trying to solve a number of subproblems that are very similar. But recursion is not perfect. It doesn't come with, it's not just a total improvement, right? It can exceed or lead to an exceeding call stack, or stack overflow, as it's called. So it's not necessarily 100% better. It's just another tool in your arsenal, just like all the many other tools that you all picked up throughout this course. So I think that is it. If there are any lingering questions, let me know in chat, but we can close out here. Tomorrow we'll be going over merge sort, where we'll end up using recursion to help us solve a sorting problem.